So let's move on and talk about exponential functions and logarithms. So let's first write down some of the important formulas. So let's say you are given y equal to e to the power of f of x, where f of x is a function of x or any polynomial. Dy dx, if we differentiate y with respect to x, this is how we do it. F prime of x, which is the first derivative of f of x, and you repeat the power as it is. That's for exponential functions. Now for natural logs, let's say we have y equal to ln f of x. This implies that dy dx is just the first derivative of x over f of x. So having this in mind, let's look at some of the examples and exponential functions and logarithms. Our first simple example is this one. Let's say y equal to ln x. What comes after that ln? That's the f of x. So our f of x is x. So what is f prime of x? We are going to differentiate x. So x is just the same as saying x to the power of 1. So we bring down 1. Then we subtract 1 from the power. So f prime of x is equals to 1 x to the power of 0. Any number raised to 0 is 1. So our dy dx is f prime of x over f of x. So this implies that our f prime of x is 1 and our f of x is x. So that's our final answer. So let's move ahead and look at some examples. So this example is going to be on exponential functions. So y is equal to 2 e raised to 3x minus 1. And we said whenever we differentiate an exponential function, our dy dx is f prime of x, then e to the power of f of x. So let's first take down some raw data from that equation. So our f of x is 3x minus 1. That polynomial which is raised to e, that's our f of x. And f prime of x, we are going to find the first derivative of f of x. So we're just going to differentiate. Differentiating 3x, by now we should be knowing how we differentiate 3x. So differentiating 3x, we get 3. And differentiating minus 1, we get 0. So let's move on and write down our dy dx. So our dy dx is f prime of x, but in this case we have a constant 2. We're just going to refer that as a, then e to the power of f of x. So finally we have dy dx, which is equal to our a. Our a in this case is 2 by f prime of x, that's 3, e to the power of f of x, that's 3x minus 1. So finally our dy dx is equal to 2 by 3, that's 6, e to the power of 3x minus 1. So it's simple as it gets. It becomes simpler as we move on. let's look at some another example on this one is going to be on natural logarithms. Let's say we have y equal to ln x squared, let me say minus 3x. So what is dy dx from there? So let's first fetch data from the given information. So we have f of x, which is x squared minus 3x. Let's differentiate that function of x. So this is going to become 2x minus 3. dy dx for natural logarithms, just as we said, is going to be f prime of x over f of x. So this becomes 2x minus 3 over x squared minus 3x. So that's the final answer there. It's very simple if you know the formula and how to differentiate natural logarithms. So let's move on to another example. So let's look at another example. Let's say we have y which is equal to 7 over e to the power of 2 minus 5x. So there's no way we can solve that without, we have to put what's on the bottom, it has to come up to the top so that it can be simplified. So this is going to become 7e to the power of 2 minus 5x negative. So what is our f of x there? Our f of x, we can simplify, is going to be 5x minus 2. So our f of x is 5x minus 2. Our f prime of x, this is going to be 5. So we've just differentiated 5x minus 2, we get 5. So our dy dx for exponential functions, this is going to be f prime of x by e to the power of f prime of x. So we are going to have dy dx, f prime of x, we have 5, but we had another constant 7, so I put a there to refer to the constant. You can put any letter. So we have the constant 7, then e to the power of f of x, which is 5x minus 2. So our final answer is going to be our final answer, dy dx is going to be 7 by 5, that's 35, e to the power of 5x minus 2. So that's our final answer. Let's move on to another example. So let's look at those two last examples on exponential functions and logarithms. So let's start with that one on the left side. So we are given a function connecting y to x, an equation connecting y to x. We have y equal to e to the power of x to the power of 7. So let's first fetch f of x from there. So our f of x is x to the power of 7. If we differentiate that we get 7x6 because we bring down the power and we subtract -1 from the power. So dy dx is going to be for exponential functions, it's f prime of x multiplied by e to the power of f of x. So it's going to be f prime of x multiplied by e to the power of f of x. And this is our f prime of x, that's 7x to the power of 6 by e to the power of f of x, which is x to the power of 7. So that's our dy dx. Final answer, dy dx. Let's move on to that example on the right hand side, which is on natural logarithms, how to differentiate that. So we just need to find f prime of x from f of x. F of x is those values that are in brackets. We have e to the power of x plus x cubed. So from there, we can calculate f prime of x. Whenever we differentiate e to the power of x, we get e to the power of x. You should know that the first derivative of e to the power of x is e to the power of x. Plus, we bring down that 3 and we subtract 1 from 3. So dy dx is just f prime of x over f of x. So our final answer, therefore, dy dx is equal to e to the power of x plus 3x squared over f of x, that's e to the power of x plus x cubed. So that's our final answer there.